Alright, so if we're wanting to do something like one of these, we could draw it as a part and everything, but there's also another way to do it called the shaft command, or the shaft tool. And so, instead of starting a part, what we're going to do is we're going to start an assembly. So I'm going to do a new assembly. And so within the assembly, if I go to design, you'll have a lot of extra little things in here. So I've got things like the frame generator, which we'll cover in 4D. We've got gears, bearings, V-belts, keys, splines, which we'll talk about today a little bit, springs, bolted connections, and we have shafts right here. So I'm going to do a shaft. And so you can start up, actually, what did I forget to do? Make a project, right? Because right now it's going to save it wherever I was done. So I'm going to cancel that. Come on.
Just warming up.
Come on. Come on. Chugga, 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 chugga. Any day now.
Computer freezing on you?
Any day now. And it crashed. Good. Let's try that again. So here's another example of a shaft. What we could do. Alright, so we're going to go to new projects. Do a new project, single user. And this could be part of a bigger project that you already had going. You already had an assembly working, then you just needed to put some shafts in it. So then you go to the shaft command then. So we're just going to do a standard assembly. So design, shaft. And tell me that I have to save the document before I use the Design Accelerator. Say OK. And I'll just do that. Now it takes me to this box. And so I can kind of see here what it is. And so if I look at it, it kind of starts from wherever my mouse is. And right now I've got 4 sections. So I have a cylindrical section that's 2 inches diameter by 4 inches in length. Another cylindrical, which is 3 inches in diameter by 3.5 in length. A tapered that starts at 4 and goes to 3, and it's 4 inches long. Then another straight one that's 2 inches in diameter and 3.5 long. Also here I can see that this section has a chamfer on the near side and a fillet on the back side. And this section has a chamfer and a sharp corner, a chamfer and a fillet, and then two sharps. So if I look at that, chamfer over there, fillet here, chamfer there. And so I can kind of define all of that in one box. So I can tell it no feature chamfer fillet, lock nut groove, thread, a keyway groove, clear the round end. So tell it a keyway groove like that. So they can end mill and go into it that way. Tell it just a ring groove where it's a thing going that way. can see as it comes up, it gives me boxes for it. Or you do the chamfer. Here I have the option of a cylinder, a cone, or a polygon. I can change that to a polygon. And now I can add the chamfer back in. But I can't do a fillet on that other side. If I pick on it, it can tell me what it is. So right here is a little drawing that tells me what all the dimensions are compared to the dimensions that I just need to fill in. So I change that back to the cylinder. So I can add new sections. Like the little X here, it'll take a section out. I can split that current section into two pieces. There's insert in a cone, insert in a polygon. If I look at this one, when I'm going this way, I don't have the lock nut groove and everything, but I do have reliefs. So why would I use one of these reliefs?
Well,
Well, this is a shaft. It's probably not very welded for on it. Why would I use a relief like that instead of a chamfer or a fillet there?
you're gonna put the rubber rings on it, or seal.
Not really.
Is there a machine?
Yeah, we could I think we just need another tool to get into that relief. But yeah, if we did a relief like that one for B, it would be easier to machine. But what else? Or G would be easier. F and A would be a little harder. But why would we want to do a relief instead of just a fillet there? Because the fillet will be just off by the lathe tool. They always have little fillets on them, so we'd just leave that in there. So why would we do a relief instead of just doing a fillet? Yeah, it's easier to make stuff fit together, right? So if we had a part like that, the part that's sitting, that slides on there, kind of want to go that far. It can't go all the way, unless we added a chamfer in here, and then we could get it all the way, right? So if we wanted this to fit all the way flush, chamfer it so it can go in. By doing a relief, now that part can go all the way.
So it makes a little deeper so it can go flush?
Yeah, because now there's not material there. And why don't we just do that at a sharp corner? When I just do this, the black corner just sharp. What? Yeah, when you have curves, it's stronger because whenever there's a sharp corner, it's a breaking point. But also, it's really hard to get a sharp corner on a tool. So cutting tools can't really have exact points, because that's the point's just going to break off. So cutting tools always have some kind of a radius on it, so that they'll actually last. So that's why we'll do that. So I can pick that here. Say I just want to fill it though. I can also from here add other things. So I can add a keyway groove. And then if I just press on this little ellipsis, I can come in and change and edit. So X is the dimension from the edge, so if I set half an inch from the edge, I can say it from the first edge, or the second edge, or center. If I have the content center set up right, I can click here and actually pick an item from the content center and pull it in, and then it would size it accordingly. Also, when you're doing this, you need to look at where this is going. So this X is going to the outside of it, not the middle of it. So if you look at this drawing, where's this drawing dimension into? The center of it. So if you're going to put it in, you need to take that into account. When you put it in, it's going to want to do it from the outside. And you can do multiple features too. So I can do that, you can do a retaining ring. Again, if I had the content center loaded, I need to work on seeing why it's not working. It was supposed to. The X will just get rid of those things. A wrench, and that does puts flats on it. So it does flats, and you can put a wrench around the pipe. Relief, a through hole, a groove, or a groove kind of that way. And when you hit OK, what it does is it finishes all that, and then you can set it in. And it fixes it where you put it in. And it's there. When I hit save, watch what happens. And save it wants to make new files. So what it's going to do is it's actually going to make 2 new files. It's going to make a new assembly, see the shaft1.iam, and then a part, the shaft1.fut. And it's taking that from the name of the part over here. But look where it is.
My document.
It's in my project folder. So my project folder is my documents Inventor shaft. So it's going, my documents Inventor shaft. Then a folder called assembly1, which is the name of my assembly. And then a folder called Design Accelerator and then the parts. So this is where it's really important to have your project set up. Because if this is going to go into your project, wherever your project is, so if you don't have your project saved in that folder, it's going to go somewhere else. And if you don't have a project picked at all, so like if you have default, it's just going to go wherever. You're not going to be able to find it. So you want to make sure that you have the project so that we don't go into that. So I'll say yes. Yes. List all. So it saved that. Now let's say I want to do something that I couldn't do on that thing. So like on that there was no way to put this screw right here in. I could do the wrench where it cut off both sides, but there's nothing to cut off just one side. Or let's say I wanted to have a hole going in that way or something. I could do a hole down the middle. So if I want to edit that, I can right click on it, edit using Design Accelerator. Let me change this one. I'm just going to take that one out. Yes. I'll change this to be Spline. And then if I go here, I can say bore on the left or bore on the right. So if I go bore on the left, it's going to do a hole. So I can do a hole, or do a hole. I can tell it what size to make. If I hit this lock button right here, it goes all the way through the whole part. So lock it, we'll change it from part way to all the way through. So I can say I want a half-inch hole all the way through, or maybe just an inch deep. And I could do another bore on the right-hand side also. And I could also add a retainer ring on the inside of that. So I could add an internal retainer ring there. Also add a thread, so I can tell that I wanted that threaded. Okay. And it's going to go through, calculate it out, draw it. But now let's say I wanted a hole going through it on this face going into it. I didn't have the option there. What am I going to do? Open the part and edit it. So I can go through and open the part from that folder, or if I just double click on it here, now it activated the assembly. Now if I double click on the part, it's going to activate the part. So now I'm actually editing the part. So now I can go in, create a sketch, turn once to get out of the part, return again to get out of the assembly. Okay? You don't want to sketch here. So I can create a sketch right here. Look at my browser. Where's that sketch? Is that in the part?
No.
No, that's up here in the assembly. And so I could do this, right? I could put cut that out there, right? It looks good here,
But once you move the part,
but once if I open that part, it's not there. Why would I possibly want to do it there in the assembly but not on the part?
modification.
Kind of. You're on the right track. You can do it there so that if after you're done made the part and you're putting it together into the assembly, you want to do some extra things like you put the two parts together and then you drill a hole between them to make sure that hole lines up. That'd be one way. That'd be a reason why you'd put it there in the assembly. So that it's not on the part drawings, the machinist doesn't see that hole, but when they're at the assembly, then they do see it. So that'd be the one reason why you do it outside of the parts like this. Or if you're doing prep for welding, which we'll do, I think next week, then you do the chamfers and stuff up in the assembly.
So if you do it on the part, the reason why you don't do it on the part is because if you make the hole first, then try to do it, it won't.
Yeah.
Just in case it doesn't line up.
If you want to make sure that they're always going to line up. But if you use good tolerances, it's not really an issue. Some places like to make sure that things are on and then drill a hole. But that'd be the one reason why you would do that. So just watch out. Don't add it in unless you're in the part for most case. So, any other questions on the shaft? You can also give calculations for loads and stuff.
When you did the grooves, can you make multiple grooves?
Yep. So if I wanted to go to this third section and put a couple retaining rings on there.
Mm-hmm.
So I could do a couple there. You do a groove there. Maybe not that big.
How do you use splines?
Good question. We'll do that next. So that's that. I'm going to go ahead and edit that. Get rid of those extra pieces.
You go to the big one?
So I just take that down to a 1 inch. I'm going to do a 1 inch spline on it. And I'm going to put it in another part. And I'm going to just take off all these other sections. I'm going to make this cylinder 4 inches in diameter. inches long. What I'm going to do on this one, I'm going to put a hole through it. And I want my spline is going to be a 1 inch spline. So right here I want to make the hole like half an inch. So I want the hole smaller than the spline is. Because when I do the spline it's going to enlarge it. And if I have it the right size, it's not going to be able to give meat down into the spline. So okay, I'll put it there and save it. So there, this is the part, the female spline. That's what the male spline is going to be. So I need to mate them together. Strain them, insert that face, align. Okay. So now they're locked on each other that way. So now I'm going to go to design. Under spline, I have the option to do a parallel spline or an involute spline. I could pick either one. I'm going to do a parallel. And what's the difference between parallel and involute? What does involute mean?
Different angles.
Always changing kind of thing. A gear is an involute, where every point on that is a different radius. And they're all tangent to each other. And so an involute spline looks like a gear tooth, whereas a straight parallel spline is like the picture. So the sides of it are parallel. So I'm going to pick, so right here it's going to give me the option, do I want to create just a shaft, just a hub, or pick both. So right now I'm going to create both of them. I'm going to do a 1 inch by 6. I'm going to tell it I want my teeth to be, that was an inch, so I'm going to say an inch, 1.25. So my shaft is going to be there. That's my reference 2. So reference 1 is picking the shaft. Reference 2 is picking the face that it's going to be going against. Now my hub, there to there. There we go. So I need to pick the outside because when I was in there, I was getting the wrong thing. So I'm going to say okay. Okay. So it's actually made that in there. And it switched it on me. So it's starting to 1 by 4, so I'll do it 1 by 6. Say okay. And why didn't it change both? But while I did that, it broke my insert because now I don't have that circle that was there anymore on the inside. If I edit that, That's on the outside piece now. I pick that one, say okay. Now it fixes that insert, but it can, and it's done. Okay. I just had to just tell it, since that 1/2 inch diameter circle wasn't there anymore, I just had to pick one of the new faces. So now that's there and it's fixed. If I took that off, I could pull it off and see. So that's how to do a spline. Any questions? No? Alright, well, that's it for today. For this. The practice is going to be working on doing this piece. What's the first thing you can tell on this one? What's different than what we've been doing? It's metric. How did he know it was metric? Yeah, what's the smallest number on there? The smallest dimension is a 1.3, and the fillets are 1.5. So either this is a really big part, or it's metric. So we're going to go with it's metric, right? That makes a lot more sense than that fill right there is 1.5 inches. So it is a metric part. Usually on metric parts, there'll be a box that says metric on it, but sometimes not. So you can kind of tell by the dimensions, or usually tell by the dimensions. So I'm going to put this on the H drive for you guys, so you can do this. So you can do most of this with the shaft command, just you're going to have to come back and edit it to add this, cut it here. Okay. And then on Wednesday, we'll do the bolt connection. Maybe if I can get the Design Accelerator to work, or the content library.